Hi, I'm Sophie Kawalec, and this is my constant velocity lab. So just to outline what I'll go over, I'll introduce my system and the purpose of the lab, the video of my object, the graph and tracker, and then when I coded the model and how that affected that graph. And then I'll show the spreadsheet of how I created the graph and compared them together, answer the questions, and then conclude that. So the purpose of this lab is to observe the motion of some object with constant speed without changing direction. So, and then I compared that with a model I created by coding it. And we'll see the results of how they start together, but they end differently, and how coding that created that result. So just some things to know beforehand. Newton's first and second law. So the first law being that an object will stay still unless force is applied to it. Similar, coinciding with Newton's second law with F equals ma, and how when that's zero, velocity will be constant. Velocity is just the derivative of position. And the system I chose with an empty Red Bull can with a mass of 0.011 kilograms, which we'll see how that is affected when I put it in the code. So let me share my video. Okay, awesome. So here we have 0, it starts at, and it's the x position is on the negative because that's going from right to left. We see here that my time starts at 0, and I'll end up coding that as well. And I'll end up using this point and this point to create my velocity by finding the derivative of the position. Now I'm going to show the code. Okay, so here we see this is where I plugged in the mass of my Red Bull can. I plugged in the initial position and the initial velocity, which we'll see how that affects the graph in the end, and the end result time of 1.2, because that's when the observed graph ended. So then we'll show. So as we see here, this is definitely more consistent than mine was. But it still starts at 0, and the x position is still negative because I'm still going from right to left with a very constant velocity, and time ending at 1.2 there. Okay. Important things to notice from that code is that F net equals 0 because the velocity is constant. I also, like I said, I put in the initial position of velocity, and that affected the graphs in the comparison. All right, so in this comparison, we see that they both start at 0, and they're pretty consistent, but the model position has more of a constant velocity because it's a code that's being looped together to create that perfect linear progression where F net is 0, whereas mine may have other factors, and it's not going to be as consistent with my video. So just some questions. What if we were to flip the axes? So if we rotate the x-axis, the speed wouldn't change because it's a scalar. So direction has no difference, but the position would be like going from left to right because it'd be positive, same with velocity. So what does it mean? Is it possible for you to say how many pushes and pulls are added together to give 0 net force in the case that you observed? Not really, because besides me being the force applied, or like the force of gravity, no other force can be confirmed, such as friction or air pressure, to create that other force to create 0. So to conclude, we discussed Newton's laws, 1 and 2, F equals ma, and how when the force is 0, velocity is constant. Some potential errors that may have affected why they weren't even is because when I inserted data into the spreadsheet, I did it by hand, so it may have created a different graph if I made a mistake there. The mass of the object may have been difficult because I just I estimated that, and how straight my roll was because it didn't change direction, but it did a slight curve towards the end. Thank you.